so to the atoms with the oxidation state equal to 0. So in such a case, in such a configuration, we are sure that the standard potential of the half cell, which include thallium, is much more lower than the standard potential in which we have a molybdenum. Yes? So the thallium is much more active than the molybdenum. So in this arrow we could place the thallium on the left side while the molybdenum on the right side. Yes? Okay, let's check the second reaction. We have thallium with the cobalt chloride. Yes? The same situation. Thallium is oxidized to the cation with the charge equal to +1, while the cobalt is reduced to the metallic state. So another conclusion, the thallium is much more active than cobalt. Yes? So we can place cobalt on the right side in comparison to thallium. Yes, on the right side of this arrow. On the right side of this arrow from, of course, versus thallium. However, we are not sure if the we are not sure if the cobalt is much more noble or much more active than molybdenum. Yes, so we need to check it in another reaction. And we have this reaction. Yes, the third one. Metallic cobalt with oxidation state equal to 0. Reaction with the molybdenum chloride. Yes, and what do we have? Oxidation of cobalt into cations with the oxidation state equal to +2, and reduction of molybdenum to molybdenum atoms in the solid state with the oxidation state equal to 0. So according to third reaction, we are sure that the cobalt in comparison to molybdenum is much more active. However, from the second reaction, we know that the cobalt is more noble than thallium. So we could place the cobalt between thallium and between molybdenum. Let's see the fourth reaction. So the last one, metal, yes, palladium here, palladium. And in the fourth reaction, there is a comparison between the molybdenum and the palladium, yes? And we could see that molybdenum is oxidized, yes, in the presence of the palladium cations, yes, palladium cations in the form of the palladium chloride, yes? We have palladium cations with the charge equal to +2. And palladium is reduced, molybdenum is oxidized to molybdenum cations with a charge equal to +3. So on the basis of the last reaction, we know that the molybdenum is more active than palladium. So this means also that palladium is more noble than molybdenum. So definitely we will place the palladium on the right side in relation to molybdenum. Yes, so we will place it here. So the most noble palladium, the most active thallium. Yes, so the highest reducing power thallium, the lowest reducing power palladium in this case.